I'd like to do an audio check. Can anyone listening, if you hear my voice, can you just type yes in the chat or just Y in the chat? Be helpful. Testing 1, 2, 3. That should be working. So I have a request for an audio check. If you can hear me, can you type Y in the chat? Okay, this is another audio check. If you can hear me, can you just type Y in the chat? This could be for anybody who's attending. Let's see. Testing 1, 2, 3. All right, I'm not getting anyone responding. I'm just going to have to assume that you can hear the audio, and so we'll proceed. So thank you for coming. Normally, these webinars are presented by Dr. Seema Maleki, but she is actually preparing to move physically at this time, and so I'm presenting this one instead, and I'm actually Daniel Filestra. I'm the founder and president of Frontline Systems. So what we'll be covering today, we'll be focusing on optimization, mathematical optimization, using Analytic Solver for Excel, but also talking about our cloud platform, RASON. Indeed, when we talk about Analytic Solver for Excel, we'll be talking about desktop Excel and also Excel for the web. Because when if you acquire a license for our software, even a trial license, actually, a free trial license, you have access to both the Analytic Solver desktop version, which works in Excel for Windows, and Analytic Solver Cloud version, which works in Excel for the web. So I'd actually like to ask everyone a question initially here. This is essentially multiple choice. You can click more than one of these choices. So I have a poll open now, and you should see that on screen. And remember, you can check more than one box, and many people will. But I'd just like to see what people, I can see some responses coming in now. See which versions of Excel people are using: Excel for Windows, Excel for Mac, Excel for the web, Power BI, Microsoft Teams. Give it a few more seconds. 2/3 of you have voted. Okay, let me go. Oh, there we go. More than 3/4 now. Thank you. And let me go ahead and close. 89%, almost everybody now is voting. I appreciate that. And let me go ahead and close this poll, and this should be sharing the results. So you can see this, and everyone has used Excel for Windows. A few people have used Excel for the Mac. Almost everyone has used Microsoft Teams, and we are finding that's true among most of our users of Analytic Solver in Excel, and it's pretty interesting. Some people are using Power BI and Tableau, and we asked that partly because you can use Analytic Solver in Excel and Power BI or Tableau together, and you can publish your model that you built in Analytic Solver, and you can publish it to run in a Power BI dashboard or a Tableau dashboard as a live model, and that's one way to get results in front of a number of people. Okay, so here's what we'll cover today. We'll be talking first about how to model and solve some sample business problems using optimization in Excel. First using Analytic Solver Desktop, and we'll also take a brief look at Analytic Solver Cloud version through a browser. And we'll spend some time on that to give you an idea of what you can do in terms of solving optimization models. Then we'll turn to the subject of how do you get the results of your model in front of the people who need to use those results. Sometimes it's enough to have the model running on your own computer and showing it to people over your shoulder. Sometimes it's enough to present the results of the model when you're giving a presentation in PowerPoint or even live in Excel at the time you're giving a presentation. But in lots of other cases, in order to really use the results of the model, you need to get those results in the hands of people who might be quite remote from you. They might be elsewhere in the company. They might be in the field sales force. They might be in other departments, other branches. We have cases where people are in a hospital, doctors and nurses, their assignments, or airline crew members who are flying around the country and getting their crew assignments. That's the sort of situation we're describing when we talk about deploying your model. And then we'll also talk about going beyond just Excel and building web applications or mobile applications based on the results of an optimization. So we'll be talking a little more than half the time about Analytic Solver, which you can think of as a authoring tool where you can create an optimization model, you can define it, you can test it, you can run it, and you can run it all the time. There's no requirement that you use RASON or use anything else. You can do everything within Analytic Solver for Excel. But then we'll also spend some time on this cloud platform RASON, which lets you do a lot of things. It underlies our version of Analytic Solver Cloud that runs through a browser. Your models are actually being solved on the RASON cloud server. And you can take advantage of that to deploy your model to other people and even to manage and govern different models that should be accessible to different people, different versions of those models as it evolves over time, and so on. So, okay, let's dive in and talk about a sample optimization problem. And this is a common problem. It's known as the transportation problem, actually, in the literature. It arises in essentially every industry where you're producing some kind of goods and shipping them to destinations. So those destinations can be customers. They could be your own warehouses, from your factories to your warehouses. They could be your own dealers, distributors, end customers, and so on. And the requirement here is that there's a certain demand from each customer, and you want to meet that demand. Similarly, at the factory side of things, there's a certain supply of the goods you're making available in any time period, and then there's a shipping cost involved in moving the goods from factories to customers. And what you want to do is minimize the shipping cost while not exceeding the supply at any factory, and while sending at least the necessary product to each customer to meet their demand. So let's jump into desktop Excel here and take a look at this in outline form. So we're here in regular Excel for Windows. We're looking at a pretty plain worksheet. In fact, all it's got in it is numbers. These are actually the shipping costs to ship a product from factory 1 to customer 1, ship a product from factory 1 to customer 2. Over here, again, just a number, just constants. We have the capacity, the maximum number of units we can make and ship out of factory 1, and similarly factory 2. And down here we have the demand from customer 1. Customer 1 needs 30,000 units, customer 2 needs 23,000 units, and so on. So how do we go from this situation to a model that we can optimize? Well, we said the very first step is what are our decisions? Our decisions are really, it'll be like numbers in here. I'll just put ones in each of these cells to start. So each one of these is one of our decisions, namely how much to ship from factory 1 or factory 2 to customer 1, customer 2, and so on. So right now, those are just cells on the spreadsheet. In a minute, we're going to define these. We're going to say these are our decision variables. But right now, we want to complete just this. We have no formulas in this model yet. So if we ship 1 unit of each to out of factory 1, then we have used up. I'm typing in sum across those 5 cells. Now that's how many I'm shipping out. If I made this 100, 100, and so on, then of course this will sum up to 500. Now I'm doing the same thing here. I could replicate the formula, just type it again. I want the sum across here. Now that is the number of units shipped out of factory 2. Then we want to do the same thing here. We want to compute how much customer 1 is receiving. So again, it's a simple sum from here to here, and then we'll just copy this formula across like that. We'll do a little formatting too, and now we have the quantities that we are shipping. Not nearly enough yet to meet the demands. We have one more formula, and that is the shipping cost. Now, how do we determine the total shipping cost of all these units to all these customers? Well, if you're familiar with this function called sum product, we use that a lot in optimization, particularly linear optimization. We first select all the cells that were that represents quantities that we're shipping, comma, and then all the corresponding prices. So the cells correspond positionally, and we get a calculated result 910, and that is this 100 times this 175 plus this 100 times this 225, and so on until we get into this row. It's 1 times 2, 1 times 250, 1 times 250 again, and so on, and that calculates our total shipping cost. Now we have a model that will calculate our total shipping cost and will calculate, how much we're shipping out in comparison to the factory capacity. And we can play what if with this, right? We can make this 100, we can make this 1,000, and we begin to see things change in the model. But there are many, many possibilities, and how do we figure out what will actually give us the minimum shipping cost while meeting these demands? Well, that's now an optimization problem. So to solve it, we can simply go over here to Analytic Solver on the ribbon. And before I go through, what these options are, you can see there's a lot more here than just optimization. And there's even more if you go to this tab. There's data mining and machine learning options as well. All of this comes with Analytic Solver. For people who have used, I'm going to ask another poll question right now to see what else people may have used. So, have you ever tried, and launching a poll so you can see it, have you ever tried solving an optimization model using one of these tools? And again, you can check more than one. The first one is this product that we're talking about, Analytic Solver, and a predecessor version of it called Premium Solver. Second version, response there is the solver that's built into Excel. This is, most people are familiar with this. It is a sort of a baby version of our optimization software, and it's something that we developed for Microsoft many years ago. And then I'm interested to know if you have used some other, any kind, optimization solver from an optimization solver from a programming language, from a modeling language, from something else in Excel. I'm interested in all those. And yeah, I'm interested to see that not too many people, yeah, okay, we've had that up for a minute, so let me go ahead and close it and share the results. And we have quite a few people online who have actually used Analytic Solver here, and that's good for me to know. It allows me to go a little deeper into the features of Analytic Solver. It's interesting to me that no one responded saying that they've used a modeling language for optimization. You can think of the Excel formula language here as one possible language in which you could write an optimization model. And when I say language, it means both the sum product and sum functions that we just typed in, and a way of bringing in the data, the shipping costs and so on, and also the selections that make it an optimization model, which we're just going to use right now. That can be done in Excel, but that's not the only way. There are high-level modeling languages, and RASON has in it a high-level modeling language, and there are also tools for programming languages, and actually Frontline offers that as well, a Solver SDK product. Okay, so far we have a model that will calculate, a number of shipping costs, but we want now to get the minimum shipping cost here, but these two cells should not exceed these numbers, and these cells should not exceed those numbers. So the way we do that, go to the ribbon. We have several steps. The first thing we want to do is click Model here, which opens this tab on the right, which has no selections in it yet. This is sort of an empty model. And then we'll use the ribbon here, and we'll define an optimization problem. So to do that, first step is, what are our decisions? So I'm selecting these cells, and this is what we want to know. We want the solver to find the quantities to ship. And we just now select here, decisions, normal. And if if I open optimization over here, you'll see that they've been defined as the decision variables in the problem. Now, for the people who have only seen standard solver in Excel, on this tab we actually bring up a little dialog that looks a lot like the solver in Excel, and you see that these decision variables are showing up here too. So that alternative, more basic user interface is also available. But one way or another, we're defining, so far we've just defined the decision variables. So now let's define our constraints. The first one is that these numbers shipped out of factory 1 cannot exceed 60,000, and the second one, product shipped out of factory 2 cannot also not exceed 60,000. And we can make both of those constraints at once by selecting them both, going to constraints on the ribbon. It's a normal constraint. It's a less than or equal to constraint. We don't want to ship any more than that factory capacity. So now I have those two cells less than or equal to, and on the right hand side, these two cells corresponding. Now I've defined that constraint. Now I'll do the same thing. That's the supply constraint. And now we're going to do the same thing here. We want to select these 5 cells, the number we're shipping to a customer. We'll pick constraints. This time we'll pick normal constraint greater than or equal to. And we want to pick here the corresponding cells for the demands from customers. So now these constraints have actually appeared over here, the supply constraint and the demand constraint. And we have one more thing we absolutely need to do, which is define the objective, the thing we want to maximize or minimize, the thing we essentially want to optimize. So here we pick this cell, the sum product, and pick objective, minimize total shipping costs, normal. The alternatives, by the way, expected and chance, arise when you have a model that has uncertainty in it. And you can also solve that kind of problem with Analytic Solver. So one more thing we should do, and that is to say, unless we tell the solver, it might put a negative number in here. We would try that. It would basically say, well, maybe I can get better results by trying that, but we know that physically it doesn't make any sense to, at least we're not accommodating returns in this model. So what we want to say here is that all of these quantities, the decision variables, have a bound on them that should be greater than or equal to 0. Okay, so now we have defined a complete optimization problem. Everything's showing up here. There's one more thing I'll make you aware of. By default, we're actually choosing the same thing that happens in standard Excel solver, the nonlinear solver, more general solver, not the best one for this kind of problem. I can intentionally here select a linear programming solver instead. But just to show you what you can do, if you turn on an option, this is the operating mode, which by default is auto help mode. If you turn on so-called guided mode, then Analytic Solver will actually help you figure out what solver you should use. So if I now say optimize solve complete problem, guided mode will start. This is a little introduction. We'll say continue. And at this moment, Analytic Solver has analyzed this model and determined that it's a linear programming model because it saw the sum formulas and sum product formula and did all the algebra to figure out that this is a linear programming problem. We're trying to solve it with a nonlinear solver, which is not recommended. So I can change this right now and say solve it with a linear programming solver. And now Analytic Solver has gone ahead and solved it. And it also can tell me the solver has found a globally optimal solution, best possible solution, because the problem is linear. And as soon as I click OK, those results then appear on the spreadsheet. So so that now people often want to turn off guided mode because it pops up dialogues and gets in their way. We recommend trying it, and let me just explain that expert mode will never bring up these dialogues. Guided mode will always bring up these dialogues. Auto help mode will only bring up the dialogues when there's a problem, and that's what we recommend. Okay, So now this is a simple example of an optimization model, and before we get into like how we might deploy this model, how we might bring it to the cloud and so on, I'd like to show you where you can go. This is a very simple problem, but where you could go with a little more elaborate version of the model. So in this scenario, we have only factories and customers. On this tab, we have a more elaborate version of the same basic problem. So now we have 2 factories as before, we have 5 customers as before, but we also have 4 warehouses. And the factories sort of, exist, they can be used in between the factories and the end customers. So it's possible now to ship from a factory to any customer. That's all of these choices. We can also ship from a factory to one of our warehouses, and it'll just be held there. And the third thing is once we've got product in the warehouse, we can ship from the warehouses to the customers. And again, we have different shipping costs for each of these possibilities. And now we can ask the solver to actually find us the minimum shipping cost. How should we ship? Should we ship only direct to customers? Should we ship sometimes to warehouses and then reship to customers? We'll let the solver figure that out for us. So this model is already defined over here. There's 3 groups of decision variables. One, factories to warehouses. You can see that defined name shows up here. And when you give a name to a range of cells, then that name will be used in this task pane over here. And then we similarly have factories to customers and warehouses to customers. There's a defined name over here too. So we can go ahead and solve this version of the model. And you can click here, or you can just click the green arrow here. And Analytic Solver will find the optimal solution, the minimum shipping cost. And you can see that it does actually make use of the intermediate warehouses, given these shipping costs and these desired quantities. But you can see that we are not exceeding the factory capacity. We're also not exceeding the warehouse capacity, by the way, and we are meeting the end customer demands here versus here. Now let's go to another level of complexity, I guess, for this kind of model. On this tab, we now have the same kind of model, 2 factories, 5 customers, 4 warehouses, but now we have 3 different products, and each customer has a demand for each different product. Okay, so it's just a larger version of the model. You can see it has 114 decision variables now. When we first started, we had just 10 decision variables. Now we're up to 114. Still a linear programming problem, though, straightforward to solve. So we click the green arrow, and Analytic Solver will run the linear quadratic optimizer, and will tell us that this is the lowest cost solution, making for all the products used in the warehouses. And then one more little step of elaboration, which is still available here, is the same story: factories, customers, warehouses, intermediate shipping costs. But now we have a certain cost, production cost of the products, and we don't want to end up, so we're actually making them as we go, not necessarily just having them in the factory. And so now we're trying to actually minimize the shipping cost and the production cost. So again, just a larger version of the model. Now it's 120 decision variables. The objective is 1 function and 51 constraints. So we can solve that problem just clicking again. And problems of this scale are no sweat at all for Analytic Solver. We have customers, but with Analytic Solver per se and no special solver engines, you can solve problems with up to 8,000 decision variables. And with our solver engines that you've probably heard about, like the Garobi solver, the Express solver, the sort of linear programming solver, so the Nitro solver for nonlinear problems, you can solve much larger problems, and some of our customers solve problems with 1 million or 2 million decision variables. Okay, so one comment here is it's going to be a little tough for me to answer questions live. because it's just me presenting. I don't have a co-presenter. But if you do have questions, just go ahead and type them in, and we'll try to answer them afterwards. I do see one question: can you run the same thing, but with integers? Yes. Look, this is a simple enough model. I'll just show you how you indicate, or how you define the fact that these decision variables should be, in this case, general integer. So you just select them here, and we view the definition of integer constraints. Really, they are a constraint on the possible values of the decision variables. So we select the variables, go to variable type bound, and just select integer here. Now, and it'll show up like this. As you might have noticed, binary integer is a special case, and that's the equivalent to integer plus a lower bound of 0 and upper bound of 1, of course. But now that will be enforced when we solve the problem. The nature of these kinds of a transportation model actually is if these constraints have integer values, then the solution normally yields an integer value anyway. But in this case, we did actually see we have the model diagnosed as linear programming, mixed integer programming, and we are actually solving it as a MEP. Those who are familiar with that. Okay. Now this is all Analytic Solver desktop. Let's take a look at the same thing in a browser. Now there's going to be a little issue of waking up this browser because it's been here overnight. But you can see that we're actually in Chrome as the browser in this case, and we are in Excel for the web, and we're on its home tab. It looks a lot like Analytic Solver. It looks a lot like Excel's tab on the desktop version as well. There are small differences, but they're easily accommodated. We have this exact same workbook. We just uploaded it to OneDrive, and we've opened it from the web. And the way you actually do this is you go to Insert Office Add-ins. This is how you do it, and then you select these add-ins. I've already got them added, and you can see that they do show up on the ribbon. Now here I might have a little bit of a refresh issue, but I bring up the ribbon. It looks just the same as it is in Analytic Solver desktop. Same thing for the data mining tab. And now if I click the model button here, okay, I get the task pane, and it does see the model. It finds the model within the workbook and refreshes it here. And now when I solve it, this is when it's going to want me to bring my license to the cloud. And let's see. Yeah, and so it's insisting that I do this. So you have a license to use it on your desktop or use it on the cloud, but not both at the same time. So I'm checking out my license, using it here, and you might have briefly seen solving here, and then Solver found a solution. So, and we actually got the same solution as you'd expect. But how did that actually happen? Because the browser is running on your computer, but it's just displaying things. The browser doesn't have any capability to solve an optimization problem or a simulation problem or machine learning, fitting data to a machine learning model. All of that happens in a cloud-based server, and it actually happens using our RASON server. So in a minute, we'll just talk a little bit more about that. Let me just check quickly for questions. Okay, yeah, and I do see that people did respond, not in the chat, but in a question box saying yes, you hear, and there's a question about the recording. We are recording that session, and we will try to follow up and send you a link. Okay, so let's return to PowerPoint for a moment here. So that's just an example of a optimization problem. This was a linear programming problem, but you can solve large-scale quadratic programming problems. Portfolio optimization is typically a quadratic problem. So two decision variables are multiplied together or multiplied by themselves. They're squared in a convex quadratic problem is sort of the next stage of complexity. General nonlinear problems can be solved, and they can be solved up to scale, not as large as linear programming problems, but we've had customers solve nonlinear problems with 100,000 or 200,000 decision variables. And then if you even go beyond the definition or the mathematical form of a nonlinear problem, nonlinear problem is normally a continuous, the decision variable and the objective and the constraints are continuous and in fact smooth functions of the decision variables. And that the big case where things are not continuous or smooth is when you use something like an if function, choose function, lookup function in your model. And I'm going to take a moment actually and show you that back in the Analytic Solver desktop. This is an example of it's actually a smaller version of a real customer model that we help the customer get running. And the customer had intended to make this a linear model, and most of the functions are like this is constant times variable, and so on. The constraints and the objective are linear, almost, but in this one little box here, and the objective depends on the calculation of the spot, the customer's using this if function. And this changes the model from a linear programming model to the worst kind of model, which is a non-smooth model. And it's non-smooth meaning that the value of the objective jumps from after it multiplies through by a fairly larger number. But every time B12 is greater than 0, it jumps from 0 to 1. And that happens here and here and here. Whenever each of these things just changes by a little bit, then the objective jumps. That's what we mean by discontinuous. So let's see what happens when we try to solve this model. And I want to put it back in guided mode, because when people don't use guided mode and they do use if functions and choose and lookup functions, that's when they get themselves in trouble. So what will happen here is if I now say solve the problem, guided mode, welcome, comes up. And at the next step, guided mode is going to look at the formulas. It's going to look at the algebra, and it's going to find those if functions, and it's going to assess their impact on the model. And it basically tells us, okay, your model is a non-smooth model. It's the most difficult type to solve. It's going to take longer. The answer may not be globally optimal. You can still get something if you just go to our evolutionary solver, which can handle these kind of models. But all these caveats apply. You know, it's going to take longer to solve, and the answer may not be proven best. Now, Analytic Solver can do something pretty fancy, which is it can actually change the algebra in your model. That is, it can take these if functions and replace them with other, essentially it creates additional decision variables and additional linear constraints that accomplish the same thing as the if functions would accomplish in your model. And it's going to try to do this. It's right now, it's going to succeed on this model and on some very large, very complex models that won't succeed. But let's go ahead and let this happen. And so Analytic Solver was able to automatically transform your model into a linear mixed integer model. And then it did it. Here's how it did it. And then now, next step is going to actually solve this linear mixed integer model. And we do get a solution. And now, if we actually look here on the model tab, this model, which started out with a much smaller number, I think it's 9 decision variables, now has 27 decision variables. All the other variables were added automatically in order to, they're hidden from view. We haven't changed the spreadsheet, but we've found a way to solve that model for you. So the takeaway message here is be aware of the issues involving the use of functions like if, choose, lookup, anything that's not that discontinuous or not smooth. Use guided mode to help you. Okay, so now let's just move on from here. I think virtually everyone who answered the earlier poll question told me that that you've done something with optimization before. Most people with Analytic Solver and other people with the Excel solver. So I'm pretty sure people are already familiar with this framework of to define an optimization model different from a what if model. You determine the decision variables, you point out, you select the objective function, and then you define constraints. And usually it's the constraints, getting them right, which is the most challenging part. You want to think about resources, like in this case, are available products to be shipped were resources. Think about physical constraints like the size of the warehouse. You can, and we had constraints in this model that are not exactly physical constraints, but demands from customers. And then policy constraints can be constraints that perform well. We are building investment portfolios, but we will not put more than 5% of our money into any one stock or any one company. That would be an example of a policy constraint. So that's how you would formulate an optimization model. Now, what happened, and we've talked a little bit, we're starting to talk now about Analytic Solver and RASON. And since this is unfamiliar ground to some people, we have a real basic explanation. What is a cloud service? What do we mean when we say RASON is a cloud service? Well, just think about like right now, you're in front of a web browser and you're watching this webinar. And so on your computer, this web browser software over here is running, and you're connected over the internet to a web server of some kind. The web server, when you type in a URL, an address like solver.com or go to webinar.com or something, then that gets mapped to, and it's actually known as an IP address, and then the messages sent, requests that you send from your browser are sent to this web server at that address. So it's a computer running somewhere, anywhere, as long as it's connected over the internet. And the protocol used is called HTTP or HTTPS for security. And part of that protocol is, for example, a GET means just fetch me that web page. And that's the most common thing you do. You click a link, it's another HTTP GET, fetches another web page. A post is from the browser is actually the message that's sent when you fill out a form. So you fill out a form, that means there's some data in the browser sitting in those form fields. And when you click submit or something, then the browser sends a message, which is a post message to the web server, and the web server receives the information that was in the form. And the responses come back from the server. Every time there's a round trip here, you make a request, you get a response, and the response normally for a browser comes back in HTML, hypertext markup language, CSS cascading style sheets, and then the browser translates that into what you see. So what if we want to do something other than just display web pages? And you probably know that a lot of web servers already do a lot more than just display web pages. Well, let's sort of fill out the whole picture here. So the RASON server runs on Azure, and it's a collection of CPUs. It's a collection of CPUs, disks, database, and so on. But it functions a lot like a web server. But the requests now come from several sources. They can come from a web application. And in fact, when we were here in Analytic Solver, within a browser, we were actually a web app. We were running a web app making a request to another web server or a cloud-based server. Similarly, your mobile phone, like almost every app in your mobile phone, is actually much like every app is sort of like a browser in it, and is making requests to a backend server of some kind. Power Apps and Power BI are Microsoft tools that are popular, that are used in the same way. And again, we send the same kind of messages. We use the same protocol, HTTPS. And we make requests, and we can send information via post, and then we get responses. And responses, instead of coming in HTML, where then they would be rendered visually, they come back in JSON. Is the most common way that data is sent back for consumption by the application. JSON stands for JavaScript Object Notation. And OData, which is often rendered in JSON, is a Microsoft standard for, you could think of this as data coming out of a database, but it can also be data coming out of a RASON server, which can be your model results gets sent in the form of OData. There's a lot of applications like Power BI and Power Apps actually that will consume an OData response directly. That's why we use it. Okay, so now we sort of build up the whole picture here. This is an elaborate slide that Seema Maleki did, but we've got everything now. There we go. So there is this RASON hosted server, and it talks to many different running applications at the same time. It runs, it talks to Analytic Solver Cloud version. We saw that. There's this front end. It's different from the RASON server. It's called RASON.com. It's a website. It's a web server, but it's really a front end portal for talking to the back end RASON server. And then your app or anyone else's a web app, mobile app, and so on can also be a client that talks to the RASON server. So, so now how do you make use of this if you're really just starting in Excel? Well, you can actually take your model in Excel. It's the same beginning model that we had, but by itself in one workbook. And you can deploy this model so it runs in the cloud as within RASON. And you do that by going to this Create App menu choice. Now there's quite a few choices here. You can and to explain a couple basics here. The first choice is going to deploy your model to run on the RASON server. And so there's a little explanation. The second and third choices are specifically for Power BI and Tableau. This choice is for running your model, maybe not in the cloud, but on your own premises, but outside Excel, using our Solver SDK. Or if you wanted to actually build it all yourself on your own web server, where you write all the code yourself, then you could use Solver SDK. And this one's a quick test. We're going to use this right now because it's a quick way to show you what's going on. And then finally, here, just to show you what this is, there's a deployment wizard. It'll take you through steps. You can respond to these questions, and it'll give you an idea of how to proceed. Okay. What I'm going to do right now, though, is just go to quick test, and I'll try this both ways. First, I'm just going to say quick test RASON model, and you'll notice it opened the other browser, which is Edge. And what happened? Okay, well, what happened is our Excel workbook model, let's go back and look at it a little bit. It's got formulas in here like sum and sum product. It's got this data and so forth. That was translated into the RASON modeling language. And if you recognize these numbers, these are the customer demands, and here we actually have the shipping costs. Here we actually have we have these are the demands and the supplies, and then here's that sum product. Notice here's the sum functions. So you can see that the contents of your Excel model were translated into this RASON modeling language form. Now, what good is that? Well, this now runs in the cloud, and just to show you that we can do something, what we're going to do, think of this as a browser. Think of this is a web client that's going to talk to the back-end RASON server. And what we're going to do is we're going to send a post message to the back-end RASON server with this body, saying this is what we're sending you, and what we want you to do is what you see in here, run that model. So, run the optimization of that model. And this time I'm actually using the shorthand version, which is called synchronous solve. I just click optimize. That sends one message to the public RASON server, post, with this thing as the body, and I get back very quickly a response saying solve a solution. And if you remember that number as the objective and final values of the decision variables, we get the same result. So I'm going through this in some detail so you can kind of get a picture of what is happening. Now, and again, remember that RASON.com is just a front end to the underlying RASON server. Let's do something at an even more basic level. We're in desktop Excel again. And this time I'm going to go to Create App, same model here. Create App, Quick Test, and this time I'm going to say web page. What does this mean? This means it's just going to generate a single file, which really is just going to have text in it. That file is going to have the file type or file extension HTML. Okay, so it's a single file .html that will contain, well, HTML, markup language. In other words, it's a web page. And so let's actually do that and see what we get. So we pick web page. Now what happened is it saved a physical file. You can see its name here. It's on our local machine, ASP1711.html. It automatically generated that file, saved it on our local computer. And because Windows is set up, oh, a new HTML file, I'll open that in a browser. It just opened it in this case in Chrome. Now, what you're seeing here is sort of a boilerplate user interface. And you'll notice that what shows up here looks like that, looks like your model again, some product, some, and so on. And indeed, if we actually click here, clicking this button is the equivalent of what we did in RASON.com, we can actually solve this model and get an optimal solution. Now, what's happening on this web page? Well, let's look at it. So we're going to say view page source. So now we're actually looking at the HTML, CSS, and JavaScript of the web page. Okay, and this was generated for you. So if any of you have seen HTML, then you're up to this point, you're probably saying, okay, that's the title of the web page. And what's happening here? We're dropping into JavaScript, which you can do in the middle of an HTML web page. And now you'll notice we have some boilerplate code that has something to do with the RASON application. Now look, now this model starting right here is the same thing we saw in the RASON editor. It's literally the same text from here all the way to the end. This is everything from here to here is one big constant as far as JSON, JavaScript object notation, is concerned. It's all constants. Now the open braces define structures, with elements, and then the square brackets define arrays. But all this is just one big constant. Everything inside quotes here is just a string as far as JavaScript object notation is concerned. But that's really a definition of your model. And if we take this whole thing and we send it from here to here, and we send it as the body of a request to the RASON server, it'll accept it and it will solve it. Now right here, we actually do that. So this function, quicksolve, is what this gets called, this JavaScript gets executed when I press that button. When I press over here the quicksolve button, then all it does is simply run this little function here. And what does it do? It goes and finds this constant RASON model. It actually turns it into a string at a little later point. Sets up a couple of parameters, but then this is the key step. It makes one so-called AJAX call, which is asynchronous JavaScript. It's an asynchronous call to the RASON server. This will have a value like rason.net. That's actually where the server lives on the internet, and it's passing these parameters /API/solve, any query parameters, and then here. This is where in JavaScript we're saying when we get a response from this web server, go and execute that function, quick status, and it will and the function receives the result from the web server, and that's exactly what happens here. Function, we receive a result, comes from this argument data right here, and we just put it into this little box down here. That's just an HTML element, and we display it, and then we display a message. So what's happening in the JavaScript code here is actually very simple, but you can see it's pretty general. And now this is a single text file that can run in a web browser, and it's completely separate from Microsoft Excel. Now the part that you're probably wondering about is, okay, great, but if I solve this, every time I solve it, I'm going to get the same solution, because the data is embedded in the model. And that's not what you would generally do. It's going to go beyond the scope of this webinar to show you all of that, but RASON has all the facilities you would need to be able to essentially say that, like, for example, this is the shipping cost numbers, or these numbers, or these numbers are actually parameters. And I want to supply those at runtime only when the model is run. And to just jump to show you what's possible, so I want to be here. Here's an example of another little optimization problem where the data is actually coming from a SQL server. And what's not so hot here, by the way, this particular SQL server has nothing particularly valuable or important in it. So the credentials to access the SQL server are just shown in the text of the model. The way you would really do this in practice is you would actually say secret connection : secret equals, and you can then use what Azure. What you're doing is you're accessing an Azure Vault where credentials to access the database are stored, and every time that Azure Vault is touched by a running application, there's a whole authentication process that takes place. So that just here I'm just trying to give you an idea of what can be done, and even this model can be run right away. And during that fraction of a second, we actually went out to the SQL server and got the data and brought it back and brought it into the model, solved it on the RASON server, came up with the optimal solution of this particular. It's a product mix problem. Okay, I'm trying to take a look here at questions. Let's see. Okay, somebody was asking about the simplex method. So you brought up on the simplex method. Good for you. I'm going to bring my license back to the desktop here. So Analytic Solver has a full range of optimization methods in it. And those optimization methods, we call them solver engines. They show up in this tab. And in this model at this time, I'm selecting standard LP for linear programming, and quadratic solver engine. That has an embedded simplex method in it. Okay, and in fact, several of the solver engines actually have embedded simplex methods. For example, as I mentioned before, the Groby solver and Express solver are often used to solve. This one too, large-scale LP solver, is used to solve large-scale linear mixed integer problems, linear programming with integer variables. And the simplex method underlies the solution of it's what is used to solve a linear programming problem like this one without the integer variables. And when you solve a linear mixed integer problem, when you do have integer constraints, there is it gets much more elaborate than this, but in a simple sense, you create a bunch of subproblems, and in each one of the subproblems, you constrain more tightly the integer variables, and every one of those subproblems is solved separately with the simplex. And then you use the results of all of these individual simplex method solves to figure out which settings for the integer variables should be used to arrive at the output solution. There's a process called branch and bound. It's the most basic algorithm. Much more elaborate algorithms are actually used in all of our software, but that's essentially how it works. Okay, let me go back to PowerPoint here for a couple of slides. So, and let me point out, by the way, there is a handout. If you see in the GoToWebinar, there's all these little sections on the right-hand side you can open up, and there's one titled Handouts. There's a PDF in there, Analytic Solver plus RASON product brief. I encourage you to just click on that and download the PDF, because it gives you a pretty comprehensive summary of what's an Analytic Solver. So as you can see, Analytic Solver can be used to create and test models, not just optimization models, but also, first of all, every type and size of optimization problem is covered: linear, mixed integer, quadratic, nonlinear, non-smooth, or sort of arbitrary models, and then models that contain only constant data, like we've been, there's no uncertainty in the model, but also Analytic Solver will solve models when there's uncertainty as part of the overall model. for example, uncertainty about interest rates or exchange rates or commodity costs. You can actually build a model that says, well, I need to ship all these products, or I'm producing products from these inputs, and these inputs have uncertain costs. How can I best handle that situation? You can do all that in the optimization part of Analytic Solver. But the same product also provides Monte Carlo simulation, rich facilities for risk analysis. The same product provides very rich facilities for forecasting, data mining, text mining, and machine learning. And there's an area we haven't talked much, we haven't offered webinars on this yet, but it's all built out in Analytic Solver to build models that make decisions using rules, business rules, and decision tables, which are sets of rules. You can read all about that in the user guide. And then the RASON server can do much, much more than we have covered here. One of the things it can do is it can not only, well, it can store your model, it can maintain model versions, you can keep run histories, which you can actually access from within Excel, just look it up there. And it can do this sort of very elaborate thing, which is multi-stage flows of models, where for example, in this case, we're partitioning data and transforming it and rescaling it and running a regression and producing a reusable multiple-meta regression model. But you can do that with different stages of an optimization model or a simulation model as well. And that's all possible in RASON. So here's where you can find out more about RASON. There's a bit of an assumption on this slide that you do know how to find out more about Analytic Solver in Excel, and obviously you can just click here, and whichever browser, this is going to be Edge, comes up to the home page of solver.com. You kind of recommend that you go here, rason.com help, and now there's quite an elaborate discussion of RASON. That's just you don't have to register or anything. You can read all about it there. Okay, so let me see if I can find any questions I might not have answered. Okay, I think I've got all the questions answered. So at this point, I'd just like to say thank you very much for attending. And if you do have questions, I would recommend just emailing consulting@solver.com. Seema Malecki, Dr. Malecki will actually receive that, but I receive it also. And I'm happy to follow up after the webinar. So thanks very much. We're right at the top of the hour. I want to wish everyone a good day, and we'll wrap things up at this point. Thanks again.